Atmospheric change led sea level rise poses serious threat to lowland coastal regions, deltic regions and small island countries. Coastal floods are these days becoming more frequent and severe even during moderate storm and high tides. Erosion of coastlines threatens many cities and ecosystem, while saltwater intrusion contaminates freshwater aquifer in the coastal regions and increases saline in agricultural soils. In densely populated deltas, sea level rise compounds existing exposures related to descending and extreme weather event. Beyond physical implication, sea level rise imposes excessive socio-economic challenges. Entire communities are becoming vulnerable to displacement. Floods and destruction due to heavy precipitation induces forced migration and widespread loss of livelihoods. Small island states are under extreme risk as even a slightest rise in sea level can warn their very existence. These evidence highlight a crucial characteristic of cryosphere change, that the processes which is happening at remote polar areas and mountainous region can impact the global consequences affecting the human societies. Changes in cryosphere-led sea level rise indicates one of the most tangible and far-reaching outcomes of the climate change system. It underlines the connection to Earth climate system and the concept of increases in temperature to reduce long-term and irreparable consequences to coastal environment and human society. So, students, now let me explain to you the atmospheric cryosphere and the ocean interaction. Now, I am going to describe three things together which you have to understand. The cryosphere plays a significant role in balancing interaction between the ocean and atmosphere, thereby regulating the changing global climatic pattern. This I have explained you in the first part of my lecture. Frozen component over the earth such as glaciers and ice sheets regulate exchanges of heat, vapor and momentum between these major earth system components. Now, any fluctuation in the cryosphere have severe consequences that widen well beyond polar and high altitude regions. Ocean ice is particularly significant in controlling atmosphere-ocean interaction. It acts as an insulating layer between the comparatively warm ocean and the cold atmospheric air, restricting the transfer of heat and moisture. Ocean ice also radiates back a large portion of the incoming solar radiation, contributing to local cooling. As ocean ice declines due to increase in temperature, open ocean areas absorb more solar energy and releases greater amount of heat and moisture into the atmosphere. Now, these altered exchange can change atmospheric pressure, wind pattern and storm tracks. The decrease of Arctic sea ice has been connected to changes in large scale atmospheric circulation that may impact mid-latitude weather extremes. Although the particular mechanism remained an area of active research, report shows that a warmer Arctic can lessen temperature gradients between the poles and the lower latitude, potentially impacting the behavior of the jet stream. This can result in more continuing weather pattern, including persistent heat waves, cold spells, altered precipitation regimes in temperate regions. The movement of cold and warm currents are also strongly influenced by cryosphere behavior through the input of fresh water from melting ice. Fresh water from glaciers, ice melt affects ocean salinity and alter its density. These alterations can disturb large scale circulation systems such as thermohaline circulation. Differences in temperature and salinity plays a crucial role in redistributing heat across the globe. A reduction of the circulation could have significant climatic concern, from regional cooling in part of the North Atlantic to change in precipitation pattern. The changes in snow cover over higher land further influences atmospheric oceanic interaction by affecting river discharge into the oceans. Seasonal variation in snow melt control the duration and volume of freshwater effect by the coastal regions by rising ocean level and temperature, also impacting marine biodiversity. Changes in the snow dynamics can consequently change nutrient delivery that affect the biological productivity and coastal species diversity. Therefore, atmosphere, cryosphere and ocean interrelatedness demonstrate the cryosphere's role as a significant regulator within the global climatic system. Alteration in the frozen conditions can have drastic consequences which can ultimately impact the whole global climate. So, I hope now, after understanding these interconnections of cryosphere, atmosphere and ocean, it is pertinent to explain to you the cryosphere impact on water resource, ecosystems and society. Cryospheric change can impact socio-environmental and socio-economic conditions of any region. It directly links climate change in polar regions to human society across the globe. One of the most important implications is on water security. How? Around 3 billion people depend on water from the river, which are directly fed by snow and glaciers for various purposes, from drinking water to irrigation. For many perennial rivers, seasonal glaciers serve as a natural storage which releases water during summer periods. Faster melting immediately raises water in river, but long-term cryosphere loss reduces this storage and leading to water scarcity during peak demand seasons among rural and urban regions. Degradation of cryosphere also raises the risk of natural hazards by many folds. Rapid glacier loss contributes to the formation and expansion of unstable glacier lakes, rising the probability of glacier lake outburst flood. This is known as GLOFS, that can cause disastrous damage to lower valley and plain regions. Thawing of the permafrost regions increases the probability of ground subsidence and incidences of landslide. These hazards extremely affect the mountainous and high latitude human societies, where infrastructure is often restricted and response capacity is low. Ecosystems from rivers to the oceans are equally at risk due to cryosphere's sudden change. A species over the cold environment faces shrinking region due to low retreat. Changed timing of the snow melt and ice cover alters food web, breeding cycle and migration pattern of the fauna, affecting both terrestrial and aquatic ecosystem. In mountainous regions, such as ecological alterations can lead to long-term biodiversity loss. For human societies, especially highland population are more vulnerable to cryospheric change. These changes threaten their livelihood, cultural practices and increases their exposure to natural disasters. The cryosphere is not a remote system, its impact can be faced by the social, cultural and economic dimension of human life. At this summary, I would like to say that the cryosphere is a significant regulatory of Earth climatic system, though it occupies a relatively small proportion of the planet's surface. Its high sensitivity to temperature change makes it one of the most trustworthy indicator of ongoing global warming. The cryosphere helps preserve climatic stability through mechanisms such as high albedo, freshwater storage and regulations of heat transfer between ocean and the atmosphere. However, anthropogenic climate change has exerted unparalleled stress on cryospheric systems worldwide. Accelerated melting of glaciers and ice sheets along with thawing permafrost and fast ice sheets mass losses are transforming Earth's energy equilibrium, disturbing hydrological cycle and contributing sustainability to rising global sea levels. These transformations present serious risk to water security, disrupt ecosystems, endanger coastal regions and increases vulnerability for human populations. Comprehending cryospheric dynamics is essential for accurate climate projections, robust mitigation strategies and sustainable adaptation planning. Protecting these cryospheric systems is both an environmental priority and a socio-economic necessity for maintaining global climate resilience.